Look at these clocks. The upper right-hand clock, there's an old mechanical clock. It's got, rather than a pendulum swinging back and forth, there's a weight that rotates on a spring back and forth and back and forth. Very consistent. Think in your mind's eye of a metronome on a piano. Click, 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 keeping beat. Or a pendulum swinging back and forth every second. A sweep second hand that clicks and clicks and clicks. For us, time seems very consistent. It flows, it integrates from seconds to minutes to days to weeks and to years. It seems just to flow constantly. It's very peculiar, though. It always flows past us. Aristotle was asked what was time, and he says it's the succession of nows. Now, now, now. And we know that now is minuscule in time. It's gone in a moment. You can't hold it. Time flows past. It's also got some strange properties. It seems to be an arrow that only points in one direction. We remember the past. We can't remember the future. Isaac Newton, a famous scientist, was asked about time, and he said, it is like unto a river. Think of the Paluxy River down here. If we stick our foot in the river and we watch the water flow past, the water that's touching our ankle, it's only there for a moment, and then it's gone. That water will not come back. It will flow down the river into the past. Time was like that for Isaac Newton. You can't get it back. The water flows past. The moment is gone. You can look downstream all you want. You can't look upstream. We cannot see into the future, but we know there is a future, and it will flow to us. We'll encounter it in the present, and then down it goes into the past. And then there's a digital clock. We've made a lot of progress since the days of mechanical clocks in Newton's time. A digital clock, when you plug it into the wall, it is actually watching the sine wave, the 60 hertz sine wave, and it's counting those fluctuations in the electricity and keeping track of time very accurately. But the bottom right clock, that's an atomic clock. That one, every morning, it tunes into the atomic clock up in Boulder, Colorado, WWV, and it hears that time signal and it syncs up extremely accurately, the atomic clock. In fact, GPS does that. The GPS in your car or your phone is probably tuned in to the atomic clock through the satellites, and that's how they maintain extremely accurate time. Isaac Newton, he developed all of his equations of motion based on constant time. There on the upper right, I listed his equations of motion. You probably learned those in high school, maybe 12th grade physics. He said that a body that is at rest tends to stay at rest. A body in motion tends to stay in motion unless acted on by an outside force. And then his second law is about the force. F equals ma. Force equals mass times acceleration. And in acceleration, the denominator has time. It's typically feet per second per second. And for Newton, the seconds were constant. Click, click, click. They never changed. His equations worked perfectly, or seemingly so. And then his third law, for every action, there is an equal and opposite reaction.